Morning, Griselda.
Good morning.
How are you doing?
Fine.
Good.
Just had a meeting from work that just ended. So
Yeah, I had to I actually was going to start about 2 minutes ago as well. I don't know if you saw my email, but here we are all ready to begin about the same time, including Megan. So I guess hopefully we get anyone else who tried to get in a few minutes ago. So, well, good morning again to both of you, and let us begin. Griselda, were you doing? How were you doing on the assignment? Have you? I don't know if you had tried to do any yet.
I actually didn't. I only finished up the previous the last assignment before this one, before
Mm-hmm.
the 1.7, and then I wasn't feeling too well yesterday. So
Okay, but you were able to get through 1.7.
yes, sir.
I mean
Well,
one
one
point
it
eight.
was yes.
Okay, good. Okay, well let's continue here, and we were. I told you there was a little more I wanted to go over with everyone on 9.1.7. And so let's do that. And um, you guys can see the WebAssign page.
Yes, sir.
Yes.
Okay. So let's see here. So 26 onward or 27, I think. But let's look at 26. And we're really just going to kind of polish this up. So let's take a look at 26 here. And you can see the parent function is so this function is a relative, if you will, of the original what function, of course. I mean, this gives it away, obviously.
The absolute value.
Mm-hmm. So we're going to put right here, the parent function is the absolute value function. And that's that. Okay. Now let's go over what these things are, these transformations, these alterations on the function. And this one has a lot of them. Yeah. There's the +1 inside the function. And remember, when you add or subtract to make a change or a transformation on a function, then that's a shift. The formal word for shift is translation, which sounds a lot like transformation. Transformation is just the general name to change a function, and there's several categories of ways to change a function. So there's several categories of transformations. There's translations, and that's when you add or subtract that kind of change, either inside the function or outside. Inside is horizontal, outside is vertical. Just summarizing everything we did the other day, which took several hours. And so this one is a horizontal translation. And what have we been saying often, that when you have a horizontal transformation, in this case a shift translation, then you do what? Do you do what the mathematical operation reads to us, or do you do the mathematical inverse of that?
The inverse.
The inverse. So this means what? This graph is the parent function is going to be moved. We start on the innermost part here that's inside the next to the x, inside the function, inside the absolute value parent function. And there's only one change inside here, one transformation, and it's the +1, which is a shift, a translation, and it's a horizontal one. So that means we would take the basic absolute value graph, and which looks, oh boy, something like that. And we would do what to it, Megan?
It's gonna shift 1 to the left.
1 to the left. So all of this moves this way, 1 unit to the left. So this point and every point. So that would give us something like this. And it's just a sketch, as you can clearly tell. And oh, I'm gonna mess it up. So that's just this part only. Yeah? Is that part okay?
Yes.
So that's one of these down here. So which one is that? Of course, Megan, you already said it.
A horizontal shift 1 unit to the left. So the last one.
Good. So we're going to click that box. And now we look outward from the inner function. And it's kind of like our mathematical operations. With like PEMDAS, or you do inside the grouping symbol, which is in this case like inside the function first. Anything that is inside that needs to be done, which was this horizontal shift. Then we look, there aren't any exponents going to be like this, but I mean it could, but then we would look for multiplication or division. And we have multiplication right here. And after that, if there's any addition or subtraction left, which would have to be outside the function, then we would do that last. So this one's the last one, okay? And this is an addition or subtraction. So then again, this is under the category of shifting or translation. And then this is what? Since it's outside the function, is that a horizontal or vertical?
Vertical.
Vertical. And do we do the inverse of what this says or what it says?
What it says.
Which would be what?
To move down 3.
To move down the whole graph 3. And that'll be the last thing we would do, okay?
Mm-hmm.
Griselda, okay so far?
Yes, sir.
But what is before that? Vertical shift down 3 units. It's this multiplication. And really, this is 2 mathematical transformation. It's the multiplication of -1 and the multiplication of 2. And these two, -1, when we multiply by -1, that's another category of transformation, which is reflection. And multiplying by 2 is the last category of the third one. Not there's a particular order, but it's the dilation that we talked about that was a little more complicated to discuss, and that took us a long time last class. So when you have both of these here, it won't matter which one you do first. You can choose to do the reflection, that's the multiplied -1, or the dilation first, whichever one we want. Multiplication is commutative, so it doesn't matter if you have 2 times 3 or 3 times 2, you still get 6. So it's like that when we do these transformations. This is 2 multiplied numbers, and you can do whichever one you want to do first. So now what kind of dilation? If it's multiplied inside the function next to the x, well, inside next to the x dimension, that's always a horizontal dilation. Then it's easy to get confused on these words here because well, I'll just hold on that. If it's outside the function and we have a dilating effect, then it's a vertical dilation, and vertical is up and down, and that means either shrinking closer to the x-axis or the points stretch further away from the x-axis. If it's inside a multiplied number, not -1, because that would be a reflection. If it's a multiplied number inside the function next to the x, then that's a horizontal dilation. And that's when the points on the graph, either they move horizontally, left and right, and either they move a shrinking closer to the y-axis or they stretch away from the y-axis. And if it's inside, you do the mathematical inverse of what it gives us. If it's outside, we do what it says. So that's kind of a lot of information, but that's what we did very slowly in the 3+ hours, almost 4 hours, I think. Ooh, I cringe just thinking about that. Anyway, so yeah, so we can do, what's this out here then going to be, Megan? Multiplied 2, is that what category does that fall under? Translation, reflection, or dilation?
The -1 and the 2?
No, just the multiplied 2 only.
Oh, just the 2. Translation?
So translation is when we shift the whole graph and move it left or move it right or move the whole
Oh, so that's the other one.
It's the dilation.
Dilation.
Dilation, And is it inside the function next to the x, which would mean a horizontal dilation, which means shrink it closer to the y-axis or stretch it away from the y-axis? Or is it outside the function, the multiplied 2, which would be a vertical dilation? And a vertical dilation is either the points are stretched closer, like 1/2 closer to the x-axis, or if it's stretched away, then it might be twice the distance away or 3 times the distance away, whatever it is. So which one is this one if it's outside?
It's a vertical.
And when it's vertical, do we do the mathematical inverse of what it's saying, or do we do what it says?
We do what it says.
So what does it say? Don't think of it as times -1, just think of it as times 2. So times 2 would take a point, pretend this was 4 units up, pretend this was a 4 up. And this distance then is 4. Yeah, this distance is 4, just pretend. And now if we do a vertical dilation of factor 2, you do what it says, and that means what then, Griselda? Move it, shrink it closer to the x-axis or stretch it away?
Shrink it towards the x-axis.
So what would be towards, if we move this point towards the x-axis, would that be a stretch or would that be a shrink?
A shrink.
And what is the times 2 tell us to do when it's a vertical one? You do what it says. If you take I don't know, if you take a rubber band and then you stretch it by a factor of 2, now it's going to be twice as long. Yeah.
Mm-hmm.
So then that means a stretch. So this point right here, if you perform a vertical dilation of factor 2, multiplied number 2 or scale factor 2, then this point, the distance from this point away from the x-axis is going to stretch. Yes, Griselda?
But it's a negative.
But what do we do? What are we trying to say about this -2? Do we think of it as one transformation to perform and to do, or do we are supposed to think of it as 2 separate ones?
I would say as one.
I know maybe that's what our mind, our intuition would say, because if we see a number and we see -7, we just think of it as one number.
Mm-hmm.
And that's fine. But when we're talking about performing a transformation on a function or on a point, you have to break it up as 2 things that have to be done.
Mm-hmm.
The -1 is always the multiplied negative is always a reflection. And maybe I can do it another way. And this is going to be a dilation.
Okay.
And maybe another way to emphasize that would be by showing you something on Desmos, okay?
Mhm.
So I'm going to do that. Go to Desmos, if I can find it. Okay. So I'm gonna, well, I'll pick the absolute value function. That's exactly what we're looking at. So y equals absolute value right here of x. And there is the parent function. Yeah? So far, so good?
Yes, sir.
Now let's do the first transformation that was inside. You always start inside the function. What was the first thing they asked us to do? It was inside the function, and that was x
Plus 1, which is the inverse, would be -1.
Very good. And you see how the blue graph is moved to the left 1 unit?
Yes, sir.
This is not a shrink towards the y-axis or a stretch away from the y-axis, which would be a horizontal dilation. This is taking the whole red graph and moving every point a whole unit leftward. Yeah? So it's not changing the rigidity or the basic form of the shape of the graph. Remember I was telling you like key points to understand? If you go 1 unit over, then, oh, this is 1. If you go 1 unit over, you should be land back on when it's 1 unit up. If you go 2 over, 2 up. 1 to the left, 1 up, you should be back. Now look at this blue graph. It hasn't changed its form or its rigidity. It's still, if you go 1 to the right from this vertex point, 1 to the right, and if you go up 1, you're right back on top of the graph, just like the red one did. If you go 1 to the left from the vertex and you go 1 up, you're right back on the graph. If you go 2 units left and then you move up 2, you're right back on the graph. That's what we mean by it's preserving a horizontal translation shift. Does not change the form of the graph. It just moves it completely. Every point moves 1 point to the left. Does that make sense?
Yes.
Okay. Now, the next thing was multiplied -2. And if we write it like it is, negative, let me do this first, absolute value of x plus 1, well, that's the same thing, so it just went right on top of the blue one, but now I'm going to write over here, multiplied by a -2. Now you're like, presto, I got a new shape. That's just one transformation. And that's a logical thing for all of us to think, yeah? But really, that's not what happened. Because what happened is, one, the blue graph reflected over which axis, Griselda?
The x-axis.
That's one transformation. And what about the rigidity of the basic shape of this graph? Okay. Did it stay the same as it was to begin with, or did it change? Well,
it changed.
Because, very good. Because when you go 1 unit over, you're supposed to, if it didn't change its rigidity, then if you go 1 unit down, you should be back on the green graph. Did that happen, Griselda?
No.
No. You know why? Because this is really two transformations, even though it's a single multiplication of -2. The -1 multiplication reflects it over the x-axis. The multiplication of 2 is a vertical dilation because it's multiplied 2 outside of the function, so that's vertical dilation. You do what it says versus the mathematical inverse of what it says. You do what it says, which is multiplication of 2 in a vertical sense, which means these points, like for example, this point right here on the blue graph, Grisel, how about, I know it starts to look messy here, but if you go 1 unit over, then it's supposed to be 1 unit up. That's the original, and same with the red graph, like I was explaining.
Mm-hmm.
So what happens if you were to take this point right here, so I'm just going to pick one. If you take this point and you perform the vertical dilation of ×2, not the times -1, because the times -1 is a reflection. This is really the multiplication of -2 is actually, in terms of transforming a graph, it's two separate changes. One is the multiplication of -1, which reflects the graph over the x-axis, and that's why now it's opening downward. The multiply 2 is another transformation, a different category. The dilating, the dilation. And it's a vertical one, and that means the point, like this point, when you go over 1 and up 1, this point is not going to be 1 unit away from the x-axis anymore. It's going to stretch, yeah? It's going to stretch by a factor of what, Griselda?
1, 2, 3, 4, 5.
What?
Well, it would be 2 from the original.
So now where would this point move if you're going to stretch it twice the distance that it is currently away from the x-axis? It's 1 unit away from the x-axis. Now stretch it by a factor of 2. What's 2? So this is 1 unit away from the x-axis. What happens if you multiply that times a 2?
It would stretch out to -1.
Not times -2, Griselda. Just the times 2. What's the 1 unit times 2?
2.
2. So this point would now stretch 2 units away from the x-axis. So this point's going to would move all the way up here. Now it's going to start to get confusing because it landed on the other graph. But don't think about. Okay, it's so easy.
It's like the green one, but facing up.
Yeah. And now you're going to do the negative. And if you then, if you now perform the reflection of this point over the x-axis, how many units is this point up here away from the x-axis, Griselda? How far now is it away?
2.
And if you reflect it over the x-axis, instead of being 2 units up, it's going to be 2 units what?
Down.
Down. That is what this multiply -2 is doing to the graph. And you're like, well, I don't see any graph down here because what did we do first? Now put it back together again. What did we do first, Griselda?
Move to the left.
How many units?
1.
And what graph did that become?
From
the red one to the what?
To the blue one, or
blue.
Horizontal shift of 1 unit to the left.
Perfect. Then it's this multiplied -2, which is really what, Griselda? Please don't say one operation. You're going to put me in the mental hospital, okay? How many mathematical operations is this actually asking us to do?
2.
Ah, phew, thank you. They were about ready to pick me up, okay, and take me away. One of these is a vertical stretch, and one of these is a reflection. The multiplied 2 is what part, Griselda? It takes this now, we're not looking at the red graph anymore because we already shifted it 1 unit to the left. So now we're only looking at which graph?
The green one now.
Well,
Or right now, since it moved, we're looking at the blue one first.
good, good. Now we're gonna do this multiplication of 2, which would be, or we can do the reflection first, whichever one we want. What if we did the multiplication of 2 first, Griselda? Then what would this, that's a vertical stretch. What would all of these blue points do? If you pick one of them, how about this one? How far away is this point from the x-axis, Griselda?
2.
2. Maybe I shouldn't have picked that one because it's a 2. But now you're going to stretch it by a factor of what?
Of 2.
Of 2, this purple 2. And what is that going to do? What is 2 units away multiplied by the scale factor 2? It stretches it from 2 units away from the x-axis. This point is now going to be how many units away?
4.
4. Very good. And that would move it, this point would go all the way up here. You hanging in there? Keep concentrating, we're almost there.
Yes.
Is that part okay, Griselda?
Yes.
And then, what else has to be done here besides the vertical stretch? It also has the multiplication of -1. And what's the multiplication of -1? It's always what category of transformations?
Reflection.
Good. And there's only 2 possibilities. One is reflect over the y-axis. Over the y-axis will be way over here. Or reflect over the x-axis. So if this point's 4 up, then it would then be 4 down. Which one is it when we multiply a function outside of the function? If there's a multiplication outside the parent function, if it's outside, then that's reflect.
On the x-axis.
Very good. Reflect on the x-axis. On or about or over the x-axis. So we get to pick, when you have a multiplication of a negative number, you got to think of it and separate it as 2 transformations. The vertical dilation, which in this case times 2, is to take all these blue points. I just picked one of them. I picked this one and stretch it by a factor of 2, which means if it's 2 units away, I could have picked this one. How far away is this one, Griselda?
2, 3.
3. And multiply it by what dilation factor here? Time, don't say negative, I'll have a heart attack. Times what?
2.
2. What's 2 times 3?
6.
6 units. Isn't that a stretch then, Griselda?
Yes.
So this point would go all the way up to 6, which is up here somewhere. Yeah?
Yes.
That's quite a stretch. Because it was already 3 units away, now times 2, it's twice as far away. And then you would perform this reflection, the multiplied -1 over the x-axis, And what would happen to that number, that's that point that moved from 3 units away from the x-axis, now it's 6 units away from the x-axis, and now reflect it over the x-axis, and what's going to happen to this positive 6, Griselda?
It's gonna turn into a negative.
It's going to come way down here to what?
-6.
So if I scoot this graph up, there better be a point on the green graph at negative what? Right here. There better get back on the graph right at what? How far down?
-6.
And I hope I'm not wrong. And is it there, Griselda?
Yes, sir.
Yeah. What happened to now? What happened to this point, Griselda? How far away is this point right here from the x-axis? This is already the blue graph, shifted 1 to the left.
It's 1.
And so what you can do, whichever one of these transformations you want to do first, Griselda, it won't matter. You'll still end up right down here. You decide which one you want to do first. If we do the vertical stretch, how far away is this point from the x-axis, Griselda? How far?
2.
How far is this one?
1 right now.
1. And if you do this multiplied 2, that's what again? What's that called?
Dilation or stretch.
It's a vertical dilation because it's outside the function, and it's a more than 1, so that means it's a stretch. Very good. And stretch it by a factor of 2. So what happens if we stretch this distance by a factor of 2, Griselda? Now it won't be 1 unit away anymore. It'll be how far?
2.
Now don't get confused because it lands right here. But then pause, and then what else do we have to do, Griselda? What's this multiplication of -1? What does that tell us to do?
To reflect it.
Over what?
Over the x-axis.
And so what happens to this point that just started here, stretched by a factor of 2 vertically, and then reflects over the x-axis? Instead of being 2 units up, it's going to be what?
2 units down.
And is there a point right here on the green graph, 2 units down?
Yes, sir.
Does that make sense to you?
Yes.
What would have happened, Grisel? I'm not picking on you in a mean sense. I'm trying. You're here, and I'm trying to get you to participate, and you're doing great. So, what would have happened, Griselda, if you would have said, Mr. King, you know what? I'm more of a reflection lady, and so I would rather reflect first, and then I'll do that darn dilation. Okay, let's see. What would it matter? Well, what would happen, for example, to this point right here again, Griselda? What if you said, Mr. King, I want to do the reflection first? Because there's 2 things to do here. And because they're multiplication, and I told you on the previous page, if you have multiplication of 2 numbers, it doesn't matter which one's first. 2 times 3 is the same as 3 times 2. 11 times 5 is the same as 5 times 11. When we have this negative number multiplied, we have to separate it into -1 times whatever it is, in this case, a 2. And these are 2 different categories of transformations. It doesn't matter which one you do first. We were just doing the vertical dilation, stretch first. What if we do the reflection first? What would happen to this point, Griselda, if we reflect it over the x-axis? Where would it go? This one.
That would go
How many units is it right now?
1.
So if you reflect it, how many units would it be below?
1.
1. Pause, have a cup of coffee, reflect on your life. Okay, we just reflected, so we can reflect on our life. Now, what's the other thing we have to do, Griselda? What's this multiplication of 2 tell us to do?
We need to stretch it out to 2 or extend it out to 2.
You stretch it out by a factor of 2 times this original amount, huh?
Yes.
And you're right, very good. So right now, after we reflected it, it's still 1 unit away from the x-axis. It's just that it's below. Now stretch this distance times what? Dilation factor? Griselda, you said times what?
2.
There you go. And what happens when you say 1 times 2? That's now how much?
2.
2 units away from the
The
x-axis.
x-axis.
And that's going to take us where? Not only right, not here, that's only 1. It's going to take us a whole 2 units, which is down here, isn't it?
Yes.
And don't we end up back on the graph anyway?
Yes.
So did it matter when we took after we moved the graph 1 unit to the left, which is a horizontal translation, did it matter if we did the vertical dilation first and then the reflection second? Did it matter? Or if we switch it and do the reflection first, have a coffee break, then do the vertical stretch, didn't we still end up at the same place?
Yes, it didn't matter.
It didn't matter. That's why when you read this multiplication of -2, we have to understand that's 2 different transformations. It doesn't matter which one we do first. Our graph will be the same graph after we have performed both of them. So if you take this red graph, horizontally translated 1 unit to the left, you get the blue graph. Now, I'm going to erase all this. And I'm going to erase this one. So just remember this was here. Huh? Oh, can I turn it off? Oh, there you go. I just learned something there. I forgot it and relearned it. Anyway, what if we write this again, but do 1 step at a time, Griselda? Y equals, oops. I'm sorry. I erased the wrong one. We have x plus 1. Okay, now it became the purple graph, okay? That was our first transformation, which was a horizontal translation. Now we have 2 choices. We either do the multiplication of -1 first, or the vertical stretch first. So which one do you want to do, Griselda? Which one?
The vertical stretch.
So that's times what?
2.
So what's going to happen to this purple graph if we now do the vertical stretch, Griselda? Is it going to be down below yet?
No.
Or are all these points on the purple graph, they're going to stretch further away, aren't they?
Yes.
So what's going to happen to this point right here? It's 3 units away. It's going to go all the way up to how much?
6.
6. So let me move this down a little bit so that we can see it. So this point right here, it's going to move all the way up to right here. What's going to happen to this point, Griselda? How far away is this point from the x-axis right now?
1.
And so where is it going to move? How far is it going to move once you stretch it by a factor of 2? It's going to go up to what?
2.
2. And so forth. So this point is 2 units away. I maybe should have used a different color, but
So it's going to be to
this
4.
one This red one below is going to become this green one. This red one's going to become stretched and it'll become this green one. And this red one, when it's stretched, it'll become a 4
4.
and it'll be like this. So what's gonna, and what about this point? How
It
far
stays the
away,
same.
how far away is this point right here from the x-axis? Let me switch. How about Kathleen? Oh my God, I'm shocked. I thought you must have gone to like Russia or something.
Hi, good morning.
Where have you been?
I've been having issues with like Zoom meetings. Sometimes I'll have them like at 11, so I won't be able to join this one.
Oh, so because you have another class that has a Zoom?
Yes.
Okay. And then have you been watching the video recording?
I have actually. They're really helpful.
Okay. I know they're really long, huh? But you can,
They're actually kind of a little bit, but not that much because it's the same pace that I'll be going with it.
say it again.
It's like the same pace.
Oh, pace. Okay, I see.
Yes.
So then it's okay, huh?
Yeah.
Okay, good. Well, I'm glad to hear that. What's your other class that you have to go to for Zoom?
Architecture.
Architecture?
Yes.
Which one is that you're in?
The first one, actually, introduction.
Okay. My daughter is in that program as well.
Oh, really?
Yeah, her name is Sabrina King. Mhm.
Sabrina King. I don't know if she's in my class.
But she's already she's already had like 3 or 4 classes already.
Oh, this is barely my first one.
Yeah, so that's probably why you haven't met her. But anyway, okay. I'm sorry, lost focus here. So this point right here, Griselda, is there any distance from this point right here? Is it away from the x-axis or is it right on the x-axis?
Right on the x-axis.
So if you stretch that 0 distance times 2, that's a strange thought. Stretch 0 distance times 2, yeah? That's like saying, oh, you know what? Someone calls you up on the phone and says, how far away are you from your house? I'm 0 miles away. Well, that means you're in your house. And if you say stretch that distance you are currently away from your house times 2, whew. Are you going to be out of your house now or are you still in your house?
Still in my house.
You're still in your house. So this point right here, if it's right on the x-axis, there's 0 distance. This point is 0 units away from the x-axis. And if you stretch it vertically by a scale factor of 2, well, you're still right here because you are still in your house. So this point does not move at all when we dilate it by a scale factor of 2. Okay? So what's going to happen when you connect? Now we just did 4 points. 4 points, 1, 2, 3, and then this one, and the red went away because I covered it up with green. And now if you connect these with a line, that's going to be this half, the new graph, after you do the vertical dilation, the vertical stretch. This purple segment here, or ray, will become this green one. By the way, and the same thing is going to happen on this side. These points are going to be stretched twice as well, and so you're going to get the same idea. This was 2 units, now it's 4. This is 1 unit, now it's doubled. And so you're going to get this. This is 3 units, and now it doubles and becomes 6. So then if we connect these green ones and these green ones, that's going to be the next picture if we do this multiplication of 2 first instead of reflect. Does that make sense, Griselda?
Yes, sir.
So I'm going to put a times 2 here. And presto. Did it happen?
Mm-hmm.
Any questions from anyone else there?
No.
And then what? Griselda, what's the next thing we have to do? Because was it just times 2, Griselda? Or was it times -2?
No, it was times 2. Well, it shows -2, but I thought that negative was with the 1.
So, yeah, this part right here, we broke it up as -1 times 2, didn't we?
Mm-hmm.
So now, what part did we just do? The multiplication of -1, which was the reflection over the x-axis, or did we just do the vertical stretch?
The vertical stretch.
So what's still missing? Because now I'm going to write the next step.
The -1, which is the reflection.
So it's going to take that black graph, which now became blue, and it's going to do what to it, Griselda? As soon as we multiply this black graph times a -1, it's going to take all these points and reflect them over the x-axis. And what's going to happen to that graph?
It's going to move towards the negative, towards the bottom.
So like this point is 6 units away from the x-axis above. Now it's going to be what?
-6 from up over the x-axis.
Very good. So I'm just going to erase my little dots here. And so won't this black graph now become, it's going to be a new color, but it's just going to be down here instead, isn't it? Yeah?
Yes.
So as soon as we type times -1, ready for some magic here, presto, presto. Yeah? Is that okay?
Yes.
So really, Griselda, this multiplication of -2, it's really how many different transformations that we need to perform.
One, two.
I mean,
Or just
what was the
2?
Yeah, just 2. The multiplication of 2 was what kind of transformation? What was that called?
Vertical stretch.
Very good. And what was the multiplication of -1 called?
Reflection.
Over the,
X-axis.
okay. Kathleen, does that make sense to you?
Yes.
I don't know if you already got to see or not yet the last video from Monday. So if you didn't, then you might be lost, yeah?
Yes. I actually am a little bit lost.
So you're going to have to go back. I'm hoping this will help you as well, but you also will need, because we're doing this now faster than we did on Monday, because this is like polishing it up, okay?
Okay.
Okay, even though right now I broke it down slowly. Okay, so now, so where are we at right now? We've done, oh, and by the way, if I turn this back on, Griselda, what's this one up here that's empty? There's no color. Isn't it just times -2 instead of breaking it down to 2 times -1? Yeah?
Where, sir? I'm sorry.
The second, this one right here. You see this one where my mouse hand is? This one?
Oh, I don't see. Let me, because I stretched out the screen, so I don't see that stuff. So
Okay.
give me a moment.
Oh, I see.
Okay, which one, sir?
This second one,
Okay.
no, there's no color because I turned it off.
Uh-huh.
And this is the same thing as down here, except instead of writing multiplication of -2 like it's given to us in the homework problem, we separated it into 2, the -1 times 2, to emphasize that it's really 2 transformations that are being done.
Okay.
So if we graph now this equation, it's the same graph as this equation. It's just that it does the 2 steps, presto magic, and it does the 2 steps, but all we see is that we get a new graph. But it's really 2 things happened. One was a vertical stretch, and one was a reflection.
Mm-hmm.
Does that make sense?
Yes.
Okay, so if I turn this back on, well, it's just going to be this graph down here again, and either it's the same color or whatever this random color is that pops up. So, and I don't know where it went. Oh, I know why, because this is written above. So now this one is written later, so it covers up the green. If I erase this one, now the green will show. Yeah. Does that make sense?
Yes, sir.
Okay. So we have gone through 3 transformations so far. The original one was the parent function, which is the red one. The first transformation was this +1. I know it's out of order, but we spent so much time. I hope it doesn't confuse you. And we moved the red original parent function 1 unit to the left.
Mm-hmm.
And that
The
gave
purple
us
one.
the purple graph.
Yes.
We then multiplied by 2, which is a vertical stretch, and that gave us the black graph. The purple graph vertically stretched and became the black graph. Then we reflected it, the multiplication of -1, and that takes the black graph and reflects it over the x-axis, and we got this green graph. Any questions there?
No, sir.
And now, is there anything left? Well, there was something left on this problem. And if we go back, we just did the +1 was the horizontal translation of 1 unit to the left. This multiplied -2. The multiplied 2 is a vertical stretch. The multiplied -1 is a reflection over the x-axis. And now there's one last thing, which is after you've done the inside transformation, horizontal shift to the opposite of +1, left 1, the multiply 2, the vertical dilation, the vertical stretch from the x-axis, the multiply -1, reflect over the x-axis. Now, if there's anything left, it can only be addition or subtraction outside the function. And we do have addition or subtraction outside the function, and then subtraction of 3. What kind of category of transformation is an addition or subtraction? It's not a reflection, it's not a dilation, but it's a
Vertical shift.
vertical shift or vertical translation. And do we do the mathematical inverse of this and say up 3, or do we do what it says?
What it says.
And that means 3 vertically, shifted 3 units down. Very good. So if we go back up here and take this green graph, so I want to take this equation here, copy it, because that's where we're at. And we have one last transformation to perform. And that is, Megan, to what did you say? Shift it down how much? Did I lose you, Megan?
Sorry, down 3.
Down 3. So this green graph is just gonna, the whole thing is gonna move down 3 units. So this point's gonna move down 1, 2, 3, and it's gonna go, it's gonna be the same form as the green one. That is had that rigidity has been changed, and it's gonna look like that. And put -3, presto, and there it is. Any questions there?
No, sir.
No.
Okay, Megan, any question?
No, sir.
Kathleen, you might be still confused, but hang in there, okay? If you're not confused, that's awesome. But if you are, just bear with us here. And let's go back to the graph. I mean, to the homework problem. And now I hope it's really powerful if you can hopefully do what we're trying to accomplish here. And by reading this, you know what's being done. So, Kathleen, I'm going to put you on the spot here. So if you can't answer, that's okay. What's the +1? That's the first thing we had to do. What's that called? Which one of these?
Oh, I don't think I know this one.
No? Okay. That's okay. I don't want to make you feel uncomfortable. So, Megan, which one is this one?
It's a horizontal shift 1 unit to the left.
And then what's the next thing? Well, you have two choices. What was one of the next things?
The multiplication of 2,
And what's that called?
which is a vertical stretch.
Good.
And then the multiplication of the -1, which is the reflection over the x-axis.
Great.
And the -3, which is a vertical shift 3 units down.
Great. Okay. And now, which graph did it become? Well, we spent so much time doing it one step at a time, which is what we want. So I hope that we don't have to spend long here. So, Megan, which one does it appear to be here?
The second one on the top.
Yeah, this one right here.
Yes.
We can check our answer so far. And the parent function's correct. The transformations we did are correct. The matching of the graph, here's the one, and we got credit correct. So everything was correct. And now this strange part here. Well, I hope it's not as strange as it was before we started Monday's class. So they just want us again to write down all the transformations we did. So the original function was f of x equals the parent function was the absolute value of x. Now, the new function, g of x, is what we get, which is this graph up here we matched, is after all 4 of those transformations were done. So what they want us to, what they're trying to get us to be able to do is to say, okay, I can do that. What is this newly transformed function g of x after we performed all 4 transformations? Well, this is the picture. Up there was the equation. Now, how can you write it in this way? So you take the original function x, and Megan, what did we do first? Of the 4?
The x plus 1.
Good. Which was called what?
Horizontal shift
Of what?
of 1. -1.
Yep. And then what did we do?
The multiplication of 2.
Good. And then what?
The multiplication of the -1.
And it really didn't matter which order, right?
Right.
That's the order you picked. And I'm sorry it's squeezed in here.
That's okay.
And then what was the last thing we did, Megan?
The subtraction of 3.
The subtraction of 3. And that subtraction of 3 can be written in front of this. It could be written like this: -3 minus 1 times 2 of f of x plus 1. Or we can write it instead of By the way, and this is negative, if you put it back together, -1 times 2 is -2 times f of x plus 1. Oops. And, and instead of writing -3 out here in front, this is -3 minus, this is the second term, but if we want to instead, we could write -3 instead of in the front, we could write it at the end. So either way, which way did, how did they choose for us to do it? The minus is after instead of in the front. So now we have it. So what's gonna go here, Megan? Minus what?
The x plus 1.
Okay,
Sorry. The x plus 1 and then -3.
mhm. And this is in fun, instead of writing it like they gave us in the equation up here, it's just writing it really the only difference is instead of f of x, I mean, instead of absolute value, we just have f of x. That's the only thing. So I hope that melts away the abstraction. And now we check. Let me clear all this out though. So where am I? Click, and then out, and then check. And we are correct. Well, that's kind of intense, but that's what we need to make this, I hope, fairly simple. Let's see. Okay, let's see if we can do this one now by looking at it, but go faster. So, Griselda, what's the parent function on this one?
The x squared.
Mm-hmm. What transformations do we see in front of us, in front of our eyes here on this equation? Griselda, is there anything done inside the function this time? Is there like an x plus 1 inside? There's a plus 1, but is that inside the squaring function or outside?
Outside.
Outside. Okay, you sounded shaky there. Are you guessing or do you understand? That's like this. Y equals, let me write it this way. Or I could have said g of x. Negative, oh, by the way, Griselda, what should we think of this right here? As one transformation or two?
2.
And what's one of them? Multiplication of -1 and a multiplication of
2.
Times the
X
parent function is squaring,
x
squared. And inside, do we have like an x plus 1 inside, Griselda? Or is the plus 1 outside?
Outside.
Ah, so what does that mean? We erase this and there's got to be an easier way to, once I erase, to get back. I just don't know how. Anyway, so only thing inside this squaring is the x, which means, are we being asked to do anything inside here, Griselda? Inside the squaring function?
No.
No. You know what that means? There's no horizontal transformation of any kind going on this function. There's no horizontal shift, left or right, because there's no plus or minus inside. Is there any multiplication in front of this x here, Griselda?
No.
So that means no horizontal dilation. Is there a multiplication of -1 inside, Griselda?
No.
That means no reflection over the y-axis. So what transformations are being done? Well, nothing with inside the squaring function, so nothing horizontally is being done. There is this multiplication of -1 times 2, and then there's this addition of +1. What are we supposed to do first? Once you've looked at anything that may be needed to be done inside the parent function, then you look outside the function. Okay, now we go outside of the house, so to speak, and now there's this multiply 2, multiply -1, and a +1. That's 3 mathematical operations that this function is asking or telling us to do. What do we do first when you do these rules, so to speak, of mathematical operations? Excuse me. We do the multiplication, any multiplications or divisions before we do the additions or subtractions outside. So this is the last step. These are done first, and it doesn't matter which one we do first. What's the multiplication of 2 called, Griselda? What's that?
The vertical stretch.
Awesome. What's the multiplication of -1?
That's the reflection
Over,
over the x-axis.
and what's this?
That is the it's a vertical shift.
Good. And you do the opposite of what it says when it's vertical, or the same?
No, the same.
So that means what? A vertical shift, how many units?
Horizontal shift of 1 unit to the right.
Is that +1 inside next to the X, Griselda, or which would be horizontal, or is it outside?
Outside.
So what kind of shift is that? Horizontal or vertical?
Upward, so vertical.
Upward, good. So help us out here then, Griselda. Which one are we? Well, there's nothing inside, so it's one of these two. So you pick. Which one you want to click first here?
To select what we're doing, we're gonna do the vertical shift of 1 unit upward.
So that's the last thing.
Okay.
And what's the first thing?
The first thing. Vertical shift of 2 units upward. That one.
Is it so that you mean there's 2 shifts?
No, that's a stretch. I'm sorry.
Ah, okay, good. So vertical stretch, and then what?
And then from there, we do the reflection, which is a -1.
Good. The multiplication.
In the x-axis.
Good. And then what? Those 2 are done. What's left?
The vertical shift of 1 unit upward.
There you go. And now, well, and by the way, let's come down here and write this part, and then we'll do the graph. So, if f of x is the parent function, and Megan, which one's the parent function? Megan, are you there?
Oh, x squared.
X squared, good. And the new function is the transformed one. They're calling it g. I guess that's for great, for a great new function. Okay, equals, and what do we do to make this great new function? We take the original function, f of x, which was the squaring function. Did we do any changes inside, Megan, inside the function or only outside the function?
Only outside.
So this will stay f of x. And then what did we do? What are we supposed to do first? The subtraction of 3, the vertical shift, or whatever the number was, or the multiplication?
The multiplication or the reflection.
Good. And so what two multiplied numbers do we have here?
-1 and a 2.
And then if we wanted to, for answer purposes, we could put it back together and say times what?
-2.
Yeah. And then what's the last thing we are doing?
The addition of 1.
The addition of 1. And that addition of 1 can be written after all of this term, or it can be written in front of this term. So it could also be like this: 1 minus the positive 1 is the positive 1 plus 1, the positive is in front of the 1, minus 2 times f of x. So g of x, the glorious, great new function, is either you can write it like this, or you can write it like this. Yeah, whichever one. So we look down here and we see which way do they want us to write it. So here's the f of x. Nothing was being done inside. And so what's going to go right here, Megan? Minus what?
-2.
Mhm. Because by these boxes, the author wants us to write it this way, huh? Yeah. So minus, which really means -1 times what's in front of f of x, a times -2, and then what's in front of that?
1.
The 1. And let's check that so far. And clear this away. And now let's do it without going to Desmos. And let's just try to imagine it oops. So we take the parent function. Now it's just a sketch. We're not going in detail. And the form has not, oh yes it has. Yes it is. It does change the form, the rigidity. But anyway, so Megan, so pretend this is the parent function. So you tell us which one, there's 3 transformations being done here. Which one, there's 2 of them there's 2 of the 3 you could say I want to do first. Which one do you want to do first?
A vertical stretch of 2.
Okay. Can you describe how I would try to guess what that would be? Not guess, but approximate. What could it be?
By taking one of the points, you're going to multiply how many units that is by 2.
How many what?
How many units?
It is away from where?
The x-axis.
There you go. So whatever that unit is, you're going to multiply it by what?
By 2.
Which is going to be what then? A vertical shrink closer to the x-axis or stretch away?
A vertical stretch.
Mhm. So you would just say, oh, double that. Oh, okay, about right there. And do it for a couple more.
Yes.
Whatever this distance is, now it's going to be double that. And same thing over here. Double that. I'm just kind of sketching. What about this point, Megan? How far away is this vertex point away from the x-axis?
0, so it'll stay at 0.
and then you connect as a sketch. Oh gosh. And this is supposed to be curved. Like, and then what do we do, Megan? What else did you said vertically stretch it first. That was your choice. Now you don't have a choice. What has to be done next?
The multiplication of -1, which will be a reflection over the x-axis.
So we take this one we just vertically stretched and we reflect it over the x-axis. And then, is that it then, Megan? It was just 2 transformations required, or is there another one?
There's the vertical shift 1 unit upwards.
Very good. So this light green graph is going to move up 1 unit, huh?
Yes.
And so you just pick it up, and this is supposed to be the y-axis here, but just pretend this is 1 unit. And this graph doesn't change its rigidity, if you will, although I'm changing it, that's for sure, with my lousy sketch, okay? And you get that one. But I mean, okay, it doesn't look that great, okay? But any questions there? Kathleen, is it starting to make any sense yet or not really?
I think I would have to like watch the first video first to kind
Okay.
of.
So it's, you're kind of lost, huh?
Yeah, because all those lines and graphs are really complicated.
Yeah, especially mine, the way I draw them. You know, it's a lot, Kathleen, okay? Gosh, you finally joined us from Australia or wherever you went, and now you're in me. No, I'm just kidding. Okay, so now we're supposed to match. So we're looking for the final graph, which is my lousy blue one here. And now, oops, and then it marked us wrong because we didn't put anything yet, I guess. So Megan, which one is the only one here that, I mean, it's kind of obvious, huh?
It'll be the 4th one.
Yeah, because it's the only one even going down, huh? Yeah. But
Yes.
more importantly, I hope this part was understandable. Yeah. So now we click this one and check. And it is correct. Very good. So I hope it's making sense. What I want to do now is, besides clear this, is okay, let's see if we can even go faster yet. Griselda, so what's the parent function for this one?
The absolute value.
Mm-hmm. And are there any transformations being done inside the parent function, Griselda, which would mean a horizontal kind of transformation?
Yes.
What's being done?
Well, it says -1, but we're to do the opposite, which is +1. Move it to the right.
Excellent. So this is a shift or a translation, isn't it?
Yes.
So that's one of these down here, huh? And that would be the first thing we would do. Which one of these is that?
The horizontal shift, one unit to the right.
Very good. What would we have to do next, Griselda? Well, there's only two. There's the +2 and the multiplication of 3. Is it a multiplication of -3 this time, Griselda?
No.
Sorry to disappoint you, Griselda, but now there's no reflection over the x-axis this time, is there?
Nope.
Dang it. Yeah? What multiplication is it, Griselda?
3. +3.
And is it inside, next to the x, inside the function, which would be a horizontal dilation? Or is it outside?
Outside, sir.
And so is it horizontal or vertical?
Vertical.
And when it's vertical, do you do the mathematical inverse of what it says or do what it says?
Do what it says.
And what does it say?
To move the vertical stretch 3.
X.
Positive 3.
Mhm. So that's one of these down here. So which one of these is this?
Vertical stretch.
Very good. And they could have said a vertical stretch by scale factor 2. Yeah. And anything else? Is there another transformation, Grisela?
Yes, it would be the +2. It's the let me see. That is the vertical shift.
And what do you do? The inverse of what it says or what it says if it's vertical?
What it says. So
Which
it would be vertical shift of 2 units upward.
There you go. Very good. And now, so let's think about that graph. The parent function this is the parent function, absolute value of x. Okay, and then Griselda. So what do we have to, which one do we have to do first? What transformation?
The inside first, which is +1, shift it, horizontal shift to the right.
Very good. So all these points are going to move one to the right. And so we don't lose the rigidity or the basic form, even though my sketch will probably do that. But this point moves one to the right. Everything moves one to the right. So it's going to look, you know, something like this. So here we could write absolute value of x minus 1. And then what, Griselda?
Then we do the vertical stretch.
Very good.
Just 3.
Which by a factor of 3, which means take this green graph and pick a few points. And whatever the distance is from the x-axis, you do what to it, Griselda?
Times it by 3.
Times this distance by 3. Good. Whatever this distance is, you take those units times 3, which makes it a stretch, doesn't it?
Yes.
So this will be 3 times this distance. So for 10, that's another one, and the point goes like from here up to here. Pick another point. Well, that's not that far away from the x-axis. Triple that, stretch that by 3. So there's once, twice, 3 times, and maybe it goes right here or something. What about this point, Griselda? How far away is this point from the x-axis?
That one's on exactly on the axis 0. 0 on the y.
So if you stretch it, is it gonna change? Is it gonna move away from the x-axis or stay?
Stay.
Stays at home, huh?
Yes.
And so forth. Yeah. So we end up getting something like, oh gosh, that's supposed to be straight. Oh, that looks really bad. So sorry. And I cannot seem to be able to fix it. And I like to embarrass myself a lot, apparently. Yeah. Okay. And then what, Griselda? Is that it? Oh, so that part is x minus 1 first times the 3. Are there any other transformations that need to be done?
No.
No, there's nothing else?
No, I don't see anything. There's no -1 there, or it's supposed to be just magically
No,
there.
there's no multiplication of -1. Good. No reflection of,
Oh, the 2. We
ah,
forgot about the vertical shift.
you don't like vertical shifts, Griselda? So you forget about them? Yeah?
It seems like it.
It seems like it, yeah. So now we're going to take that whole graph and do what to it?
We're gonna shift it vertically upward.
And whatever 2 units is, huh?
Yes, sir.
And forgive my really bad graph, but I'm not quite sure how to draw that part right there because I kind of destroyed everything. Something like that. So now let's come down here and figure out which one is the only chance. So first of all, could it be this one, Griselda?
No,
Because this one is going down, isn't it?
correct.
That would be if you reflected it over the x-axis. So that's not right. Could it be this one?
No,
No.
because that was moved to the left.
Yeah. So that's out. So no, no, one of these two.
I
What
would
happened
say
when we took this original graph, Griselda, and we vertically stretched it, didn't we?
yes.
That means what? Does that mean this purple one opened up wider or opened up narrow, more narrow?
More narrow. So it would
So,
be the last one.
yeah. So that's this one. Does that make sense?
Yes.
We could have done it by points, but I hope this is okay. I think it's actually powerful that we can do it like that. But that's just me. So that's this one. And now this part. So let's see if we can do it without me writing anything down this time. Griselda, what did we do? Anything inside the original function? Was there any transformation done inside?
Yes.
And what was it?
It was, let me see, the original one was -1. It turns into a +1.
So we did shift it 1 to the right, didn't we?
Yes.
But what do I have to write in here so that it tells us to shift it 1 to the right? Do I write?
X -1 or -1.
Good. Then what did we do next? After we shifted it horizontally 1 to the right, we then
Stretched it
by
3.
a scale factor of 3. That's this part, huh?
Yes.
Yeah. And then what was the last thing you did?
Vertical shift by 2.
So then we could write +2 afterwards, or they can write it in the front, huh?
In the front.
They wrote it in the front. And check. And we're correct on the parent, we're correct on the transformations, we are correct on matching the graph, and we are correct on writing it in this function notation and not putting the specific parent function, but keeping it as f of x. I mean, in f of x form. So I hope we're feeling better about this. And now these problems at the bottom here. And it's the same topic, just asking us in a different way. which is very nice, in my opinion. So, let's see here. Kathleen, can you help us on this one? All you have to do is read it, and then we'll see if we can get it, okay?
Okay. Write an equation for the function whose graph is described. The shape of fx equals x cubed, but shifted 12 units to the right.
Very good. So we're going to take this parent function. We're going to get a brand new one. And G for great new function. Take the old function, the parent function, and we're going to do something to this. And they could tell us to do something inside, which means a horizontal impact, left and right kind of impact, or outside. And what did they tell us to do? And they could ask us to do 3 or 4 transformations, or just 1 transformation. And they only told us to do 1, didn't they, Kathleen?
Yes.
And what did they tell us to do? To shift the original graph, which way?
To the right 12 units.
Mm-hmm. So isn't to the right mean, isn't that a horizontal transformation?
Yes.
So we would take this graph. This is what the basic x cubed function looks like. And we just move it, all this, 1 unit to the right, and it just as a terrible sketch here. Actually, that one's pretty good for me. That's about the best I'm gonna ever do. I should take a picture, okay? This one is 12, oh, except here I was bragging, but I only moved it 1 unit and I wanted to move it 12. So we're gonna pretend that's 12, okay? 12 units to the right. Okay, so much for doing a good job. 12 units to the right. Okay, so that means everything is moved over. The original graph is moved over. That means it's a change inside the function. So you have to put it in here, Kathleen.
Okay.
Because it's horizontal. And then when it's horizontal, you do the mathematical inverse of what they tell us. So if they say shift 12 to the right, 12 units to the right, you have to put a 12 in here, but you cannot say addition of 12. You have to say the inverse of that. Well, what's the inverse of addition of 12?
Subtraction.
Sorry, my dogs are going crazy again. So it's f of x minus 12.
Okay.
So, but instead of f of x, we're going to write it in with the actual parent function. So instead of f of x, we take the cubing function, which was the parent, and we do what inside, Kathleen? We do what to the x? We shift,
Subtracted by 12.
subtracted by 12. And that's it. So that's what we put right here. So x minus 12 cubed. If we went to Desmos and checked, there's the parent function. And now we don't see anything, not because it's wrong, but because we have to move over 12. So that's a long ways over there. But the same shape is still, the shape did not change. The rigidity, fancy word, did not change. Which means if you look right here, if you go 1 unit over, and this is what we talked about on Monday, if you go 1 unit over on the cubic function, and if you go 1 unit up, you should be back on the graph. And if you look here, if you go 1 unit over, you go 1 unit up, you are back on the graph. It did not change the shape of this. If you go 2 units over, we said on Monday, then you should go, if you go up 8, because 2 times 2 times 2 cubed is 8. You go 2 units over and you go up 8, you're back on the graph. Well, that should happen here because we didn't change the rigidity. We just moved it 12 units to the right. So if we go 1 unit over, 2 units over, and go up 8, we are back on the graph like that. And by the way, same thing to the left. -1 unit to the left, 1 down, you're back on the graph. -2 over, down -8, you're back on the graph. Same thing should happen on this one because we did not change the rigidity, the form, the basic shape. 1 over, 1 down, yes. 2 over, 8 down, if we could find it, yes. So, any questions there?
No, sir.
No.
And check. Okay, let's try okay, Megan, can you read number 31 for us? Oh wait, how about 30 first?
Write an equation for the function whose graph is described. The shape of x cubed but shifted 4 units to the left, 4 units down, and then reflected in the y-axis in that order.
Yeah, that kind of can make things a little bit confusing. Yeah, in that order. So we have to do it in that, if they say in that order, then we have to do it in that order. Okay. So we're going to take, by the way, same parent function. So this is like the culminating kind of exercises for this topic. And now, what do they ask us to do in that order, Megan? What's the first transformation?
4 units to the left.
Good.
We'll
So,
have x plus 4.
and where do we
parentheses.
write that? Inside, huh?
Mhm.
Good. And I'm gonna just switch to Desmos here. And we have y equals x cubed. This is the one we were just looking at. And I just gotta go back to the graph. Okay. And we take this equation and the first thing was move it 4 units to the left. And it did that. So Megan is correct. Very good. So far, so good, ladies?
Yes.
Yes.
And now what, Megan, what was the next thing they said in that order?
4 units down.
So pretend you haven't even been told yet. This is a secret. If there's any more transformations, it's a secret. No one has told you. So this is what you have to do in this order. Okay, move 4 units to the left. Is there anything else? I'm not telling you yet. Okay, do it. Okay, x plus 4 cubed. Okay, now I'm gonna tell you the next step, but I'm not telling you if there's any more. Now 4 units down. So what would that be, Megan? Where would we, how would we write that?
It'll be outside and -4.
Very good. -4. And when it's vertical, you write what you do what it says, not the opposite like we did with the horizontal part. So if we check and see if we're correct so far, then we would come over here and now type -4, and this blue graph better do what, Megan?
Move down 4.
So presto. Now it kind of tricks us a little bit, and it looks like the shape has changed, but it's just the perspective. It's just because now we're seeing more of this. See right here, they only showed us part of it. I mean, some of it. And now since we moved it down, you see more of it because this upper part came down, and now it looks like it's a different shape, but it's not. It just kind of, it's like an illusion kind of thing. Okay, well now either we're done or we're not done.
Now reflect the y-axis.
Now, oh, the last secret, the last task, reflect the graph we have over the y-axis, huh?
Mm-hmm.
Okay, so go back.
So we're gonna put a -1 inside the parentheses in front of the x.
Okay, because when you reflect over the y-axis, then you multiply the x times a -1 inside. Very good. So let's try that. So then, like, for example, Megan, this point, for example, this point right here, when we reflect it over the y-axis, here's the y-axis. Well, it's supposed to be. How far is this point, Megan, from the y-axis right now? How far away?
2 units.
This one, the blue one.
Oh, 4.
4. And then when we
-4.
and went -4. And when we reflect it over the y-axis, it's going to be on the other side, the same distance. So what's that going to be?
+4.
Mm-hmm. So it's going to go zoop, way over to here. And what about if we pick another point? How about this one, Megan? How far away is it right now from the y-axis? Oh, well, it's not exact, but it's a little more than what?
A little more than -2.
Mm-hmm. So when we reflect it, it's going to be a little more than 2, but on the other side, huh?
Yes.
So something like that. And let's say you did one more, and I'll just go faster here. So this one is like that amount, which is about, you know, almost negative. Yeah, -5 or so. So this is going to go on the other side and be a little more than -5. Oops. Something like that. And this is a point. And this is a point. And this is a point. And I'm not very good at drawing these things, but this part, this whole graph right here is going to be reflected over there. So it's, if you guys, whoever plays those kind of video games, it kind of helps, but then get used to this. But, oh, I don't know, I'm going to destroy it. It's probably something like this. But I did a really bad job here, so. Anyway, okay, so let's find out. So this says reflect the graph over the y-axis. Move it. Okay, so I'm sorry. Let's go over here then and check. And times, so let's see if it takes this blue graph, this one right here, although it just turned green, and does it come over to this blue one, well, something like it, times -1. And I know I got too much of a mess here, but this is my lousy attempt, boy, it was lousy, to be the reflection, and this is what it's supposed to be. I mean, I had kind of the right idea. I just got too close over here. I should have gone more up like that. So that worked, huh? Megan, that works, huh? Yeah?
Uh-huh.
Okay, so very good. So now we put it in, and let me clear. And so where was this one? This one. So we're gonna write X, and what did you say, Megan? It was X.
Well, in that order, or do we have to write the -1 first?
Yeah, that's an interesting question. We're just writing our final answer, I guess, right? So
okay.
X plus 4
X
cubed,
plus 4 cubed,
and then it
and
was
then -4, and then a -1, inside.
okay. Very good. Good job, Megan. Okay, let's try another one of those. How about this one right here? Megan, can you read this one also?
31.
Yeah.
Write an equation for the function whose graph is described the shape of the absolute value of x, but shifted 12 units up and then reflected in the x-axis.
And then they don't tell us in that order, do they?
No.
That's kind of, anyway, okay. So we're gonna take, I'm gonna go back to Desmos, clear this out. We're gonna take the absolute value graph. And do what to it, Megan? It said shifted what?
12 units up.
And then, so that tells us that this is supposed to be first, huh? Yeah. So
Yes.
plus 12. So where do we write plus 12? If it's 12 units up, Megan.
It'll be outside.
And do we do what it says, the inverse of what it says, if it's vertical?
What it says.
And plus 12 is quite a ways, so that's why we don't see it, but here it is, yeah? And now what are we supposed to do to that now, Megan?
Reflected over the x-axis.
Yeah. And then, so this gets a little bit tricky here, okay? So normally, what would have happened if we did this first? Okay, what, let me, we take the original absolute value graph. Okay, and what if we would have reflected over the x-axis first? If you would reflect over the x-axis first, then it would be like this. Reflect x-axis first. It would be this brown one, huh? And then
Yeah.
what would happen, Grisel? I mean, Megan, if we said now move it up 12, what would happen to this brown one?
It would move up to where your black one is.
Yep, but it would be facing which way?
Down.
Down. And this would be 12 up, 12 units up. But we do this second step. And this is the first step. If we did that, then we would get this black graph, wouldn't we?
Uh-huh.
But they didn't tell us to, but what did they tell us to do first, Megan? Yeah, reflect over the x-axis first, or move it up 12 first?
Move it up 12.
Yeah, which is this black graph up here, isn't it?
Uh-huh.
And then they tell us to do what? First shift it 12 up, and then do what?
And then reflect it in the x-axis.
Good. So if we do this reflection first and then move it up, we get this black graph on my scribble here. And that would be our final graph. But if we do, instead of reflect first, we move it up 12 first, that's what's over here. Now reflect this over the x-axis, and what's going to happen, Megan, when we reflect this now over the x-axis? Yeah, instead of opening upward, it's going to open which way?
Downward.
And instead of being 12 units up, it's going to be what?
12 units down.
So good. So it's going to be, let's say right here is 12. And now it's going to be, oops. So if we we better get this graph, huh?
Mm-hmm.
We don't get this one, do we? This one was up above, and it's supposed to be what? Below. So Megan, that means what? If they tell us to do transformations and they tell us to do one thing first and then do another one, sometimes it makes a difference, doesn't it?
Yes.
And if we would have done it a different order, and like I showed you here, they told us move it up 12 first and then reflect it over the x-axis, and we would get this one. If we didn't listen to them and we reflected first, we get the brown graph. Move it up 12 second, and we would get this graph. And that's a different picture than the one they want. Does that make sense?
Yes.
So we have to follow. When they tell us when they tell us, if all they do is write an equation, then you follow the order of operations, inside, outside, like we've been doing. But if they tell you, hey, follow my steps, well, then you have to follow their steps. So let's see, what are we going to put here now to get the right graph, which better be this one down here. So we're going to take this, and we're going to reflect it over the x-axis. So, what do we normally do, Megan, when we want to reflect over the x-axis? We have to multiply by what number?
-1 outside.
Outside. So, times, but if I write times -1 here, class, that would be like saying, do that reflection first. And you would get this wrong graph. So if I just type -1 only right here, it's going to do this. It's going to reflect it first, which is the brown graph, and then move it up 12. And then we'll get this black graph. Yeah, and that's not the one we want. So if I put -1 here, presto, here it is. Yeah, that's this graph right here. And we're supposed to get this one down here. So that means, oh, I typed a -2. That doesn't help. Sorry. So this is not the right equation because we're not getting the right graph. We're supposed to get this one. So what that I'm trying to say, without trying to sound difficult, is if they tell us move it up 12 first and then reflect, then you have to do this, ladies. Put a parenthesis around all of it, because this means take the basic graph, Megan, and then do what first? Reflect it first or move it up 12 first?
Move it up 12.
And then isn't that what they told us to do?
Oh, yes.
And now you're supposed to do what? Because this is being told, hey, do this first. So
And
then you
then
got
you're
to put
gonna-
that in a grouping symbol because they told you to do that first. Now what do you do to reflect as a second job, a second transformation? Reflect whatever you have in front of your eyes, which is this equation and this graph, and then reflect it over the x-axis. What does it take to reflect over the x-axis? You have to multiply it by what?
-1.
-1.
But not just this piece, the whole thing, because they told us to first do this job. And if all we do is put the times -1 in on this one, we didn't get the right graph. So that can sound miserably difficult or simple. I don't know which it sounded, but so we have to put the times -1. And now it'll take this first step of moving it up 12 units, reflect it, and we're going to get the graph down here that we were supposed to get, not this one up here that we incorrectly would have gotten if we just would have said times -1 on the function only. Because they told us what to do in steps, in order. You have to then realize that, and that changes things. So now, presto, and now we have it. Megan, do you understand that?
Yes, sir. Thank you.
Did you have trouble with that when you told me you had a couple of issues? Was that one of them?
Yeah, well, I was going ahead on the homework and So I had a question about a couple that were before that, but that answered it. So thank you.
Okay, you're welcome. Let's try another. Oh, so let's go back. And then Megan, what are we gonna write here then?
It's going to be -1, and then parenthesis,
Mm-hmm.
the absolute value of x
And then
plus 12
where?
after the x
But
inside the parenthesis,
yep.
and then close parenthesis.
Okay. Hello? You know what? He just hung up. So let's just do one more and then we'll stop. And then I'll
Okay.
call back. Okay, how about, let me see here. Okay. Well, let's see. How about 33? Megan, can you read that one?
For the function graph is the shape
Are you there, Megan?
and the y-axis.
Okay, we lost your voice there, Megan.
Oh, sorry, I might not have very good connection.
Okay, so we're gonna take this graph, shift it 2 down first, huh? Yeah? So
Yes.
Yes.
Uh-huh.
how do we shift 2 down, Megan? Where do we put the 2 down?
It's going to be outside.
So last one, square root. And I guess we're not gonna do any new section today because this took a long time, but this is a big section, an important section. So we can live with that. -2 outside. And that did move it 2 units down, huh? Okay,
Yes.
now what, Megan, did they ask us to do? Then this one, then what?
What number went? Oh, 33. And then reflected in both the x-axis and the y-axis.
Okay, so when they tell us, so okay, x-axis. So to reflect over the x-axis, and they told us what? Is this, are we supposed to do that first, Megan? Reflect over the x-axis and then move it down 2? Or first move it 2 down?
Move it 2 down,
So then we got to put this inside of what?
a parenthesis.
Very good. And then reflect over the x-axis, just like the last problem. You got to put this in a parenthesis, the 12 up, and inside the grouping symbol, and then times -1. So what's going to go out here, Megan, for the reflect over the x-axis?
-1.
Good. Go to the graph. Put a parenthesis around it. this green graph is gonna get reflected over the x-axis, which means this part is gonna come underneath. This green part is gonna go zoop, and this green part is gonna go zoop. So it's gonna look something like and this part is gonna go, oh gosh, I just lost it. Sorry. Well, this will be, this is when I start to get nervous and then I can't see it here. I did see it just a moment ago. If you reflect it, it's gonna go like that. I don't know. I just lost it. So let me graph it. Put here times -1. And that's what I was supposed to see. Okay. And this green part goes up. And it kind of confused me because I drew this too sharp right here. So this comes up. And well, anyway, so, okay. Now what? Is that it, Megan? And just the reflect over the x-axis? Was that all?
No, and reflect over the y-axis.
Ah. So now we have to take the purple graph and reflect it over the y-axis. And this whole purple graph is gonna now go something like this. So how do we reflect over the y-axis? Yeah, Megan, what kind of multiplication do we have to do for that?
-1, but it's gonna go inside the parentheses with the x.
Okay, so and right here times, oops. And there we go. Does that make sense, ladies?
Yes.
Okay.
Do you have to put the multiplication symbol, or can you just put -1x?
No, you don't need that. No.
Okay.
Perfectly. You don't even need the negative. You don't even need the 1. Oops.
Just a negative.
I was just trying to emphasize it. Yeah.
Okay.
Oh, I erased something, but yeah. Does that answer your question?
Yes.
So let's go back and type this answer in. And we have, so it was
-1 outside of the parentheses. And then we have the square root of -x.
then,
And outside of the square root symbol is -2. And close parentheses.
let me check. And we are good. Yeah.
Yes.
A little tough, but I hope it is okay.
Well, this was really helpful.
Yeah. Well,
Yeah.
Thanks for your patience, Griselda. I hope you're okay.
Yeah,
Little bit.
It's a little confusing, but I'll just be going back to the video.
Okay. And then tomorrow, so there's only a few left. So try them. I tried to do the more difficult ones, but try the remaining ones, and if you have question, you can chime in tomorrow at 10:50 for the office hour as well.
Okay.
If
Okay.
you have questions, okay?
Okay.
Okay.
Yes, sir.
Kathleen, you're probably lost, but I hope you learn something from this, and then when you go back and look at the first video, you'll come together, okay?
Yes. And then if I do also have some questions, I'll also tune in tomorrow.
Okay. Did it help? You feel like you learned a little bit here, or you just kind
Yeah.
of got worse and worse, or okay? I hope you learned something, okay?
Thank you.
You're welcome. Okay, ladies, thanks for your patience and participation. I appreciate it, and I hope it helps you. And maybe we'll speak tomorrow. If not, next Tuesday, okay?
Yeah.
Okay. Thank you.
Okay,
Thank you.
you're welcome. Okay, goodbye.
Bye-bye.
Bye. Have a good weekend.
Too, thanks.
Thank you.